Hello viewers, in today's session we are going to discuss one very important problem from definite integrals, right? So here we have to evaluate this integral from 0 to half, and we have dx over x minus 1 whole square times square root of 1 minus x square, right? So here we'll see how to find out the values of these type of definite integrals. So now let us first take the general case, right? So here we'll see the type of integrals, that is dx over x minus k raised to r, and here we have a quadratic polynomial, that is ax square plus bx plus c, right? So our given integral is of this form, and here we have the limits 0 to half, and if we take the indefinite integral, then this integral is similar to this one, right? So here we have x minus 1 raised to 2, here we have x minus k raised to r, right? And inside the square root sign, here we have a quadratic polynomial 1 minus x square, and here we have a quadratic expression ax square plus bx plus c, right? So let us see how we can integrate these type of functions when the integrand is of this form, right? So here what we do, we take x minus k is equal to 1 over t whenever x is greater than k, right? So we take this linear factor, that is x minus k, and whenever x is greater than k, we take this substitution, that is x minus k is equal to 1 over t, right? And when we have x that is less than k, then we take the substitution k minus x is equal to 1 over t, right? So to solve these type of indefinite integrals, we take these two types of substitution depending upon the relationship between x and k. So when x is greater than k, we take the substitution x minus k is equal to 1 over t, and when x is less than k, we take the substitution k minus x is equal to 1 over t. So now let us take this integral I. So we can now write I as 0 to half. Here we have dx and x minus 1 square, and here inside the square root sign we have 1 minus x square. So this is of the form 1 square minus x square, which can be factorized as 1 minus x 1 plus x, right? So here we write 1 minus x 1 plus x. Now if we look at these two terms, we see that to exist or to be valid this term, we must have 1 minus x should be greater than 0, right? Because we cannot have a negative sign inside the radical sign in the set of real numbers, right? So for the validity of this integral or this integrand, 1 minus x should be greater than 0. It means 1 should be greater than x, right? So if we compare this inequality with this one, then we can see that here x is less than 1 and the value of k is equal to 1, and here we have x minus 1 square. So here we have x minus k square, so the value of r is equal to 2, right? So to solve this integral, we'll make this substitution, because x is less than k and k is 1, so x is less than 1. So we'll take the substitution, that is 1 minus x is equal to 1 over t. So here the value of x vary from 0 to half. So let us find out the value of t, that is t is equal to 1 over 1 minus x. So when x is equal to 0, then t is equal to 1 over 1 minus 0, that is equal to 1. And when x is equal to half, the value of t is 1 over 1 minus half, that is 1 over half, that is equal to 2, right? Okay, so now here we have 1 minus x is equal to 1 over t, so that x is equal to 1 minus 1 over t. So let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of 1 is 0, and here the derivative of 1 over t with respect to t is minus 1 over t square. So this is minus minus plus, so we have 1 over t square, right? So now dx can be written as dt over t square, right? So now let us rewrite this integral I in terms of t. So now I can be written as the limits vary from 0 to half. So here t varies from 1 to 2. So here we have 1, here we have 2. And for dx, we can now write dt over t square. And here we have x minus 1 square. So x minus 1 may be written as x minus 1 is equal to minus 1 over t. So x minus 1 square is minus 1 over t square, that is positive 1 over t square. So here we have 1 over t square, and then we have square root of 1 minus x square, right? So x is equal to 1 minus 1 over t, that is t minus 1 over t, right? So here we take the LCM, so t minus 1 over t. So here we have 1 minus t minus 1 over t square. So now let us look at this term. So here we have square root of 1 minus t minus 1 square is t square plus 1 minus 2t, and in the denominator we have simply t square. So now we can write it as t square minus t square minus 1 plus 2t over t square, right? So t square get cancelled, and now we have square root of 2t minus 1 over t, right? Because the square root of t square is t. So now we can rewrite this term or this integral as 1 to 2, and here this t square and this t square get cancelled. So we are left with dt over square root of 2t minus 1 over t. So this is 1 to 2, and this t can be taken to the numerator. So we have t dt over square root of 2t minus 1, right? So now we have to solve this integral. Let us make another substitution to solve this integral. So now let us take 2t minus 1 is equal to say u square. So here we are introducing a new variable. So u square may be taken as 2t minus 1, which implies that u is equal to square root of 2t minus 1. So now differentiating both sides, so we have d 2t minus 1, here we have d u square, right? So this is the derivative operator. So the derivative here we have simply 2 dt, derivative of 1 is 0, and here we have 2u du, right? So the derivative of u square is 2u. So this 2 and this 2 get cancelled. So we are left with dt is equal to u du, right? Now here the limits vary from 1 to 2. So let us take t is equal to 1. So when t is equal to 1, u square is equal to 2 times 1 minus 1, that is 2 minus 1, which is 1. So u is the square root of 1, that is 1, right? And when t is 2, then the value of u square is 2 times 2 minus 1. Here we take t is equal to 2. So this is 4 minus 1, that is simply 3. So u is square root of 3, right? So when t goes from 1 to 2, u goes from 1 to square root of 3, right? So now this integral I may be written as that is 1 to square root of 3, and here we have t dt. So t is now equal to u square plus 1 over 2, right? Because 2t minus 1 is u square, so 2t is equal to u square plus 1. So t is equal to u square plus 1 over 2. So here we have u square plus 1 over 2, and for dt we can now write u du, and here for square root of 2t minus 1 we can write u. So u and u get cancelled. So now we have I is equal to 1 to root 3, and here we are left with u square plus 1 over 2 du. Taking half outside, and we have 1 to root 3 u square plus 1 du, and now we can find out the integral of u square is simply u cube over 3, and here the integral du is simply u, and limits are from 1 to square root of 3. So let us substitute the limits. So we'll take square root of 3 here. So we have square root of 3 cube over 3 plus square root of 3, and then we have 1. So this is 1 cube over 3 plus 1, right? So we can simply solve these two expressions. So this is 3 root 3 over 3 plus square root of 3, and then here we have 1 over 3 plus 1, that is equal to 4 over 3. So here 3 and 3 get cancelled, so we have half, and square root of 3 plus square root of 3 is 2 times square root of 3. Here we have 4 over 3, right? So now multiplying these two terms by half, this 2 and this 2 get cancelled, so we have square root of 3, and here 2 2s are 4, and we have here simply 2 over 3, right? So viewers, the value of this integral is given by square root of 3 minus 2 over 3. So we can also write this expression as 3 root 3 minus 2 over 3, right? So this is how we can solve these type of definite integrals.